Hey guys, long time no see. So, in this set of videos, we're going to be talking about organic chemistry. It's a whole new section of chemistry. There are multiple chapters, all interconnected. So we're going to try our best to just acquaint ourselves with the keywords and basic techniques of how to address the concepts of organic chemistry. So we'll find it really easier. Trust me. Organic chemistry, as we know it, it's a branch of chemistry. It's a branch of chemistry that deals with hydrocarbons and their derivatives. So there are two new words for us, the word hydrocarbon and the word derivatives. So we're going to be seeing what the word hydrocarbon means and what the word derivative means. So we're going to be dealing with hydrocarbons and their derivatives. The word hydrocarbon means compounds that contain hydrogen and carbon atoms only. So they have only hydrogen and carbon atoms. A hydrocarbon cannot be having a sulfur atom, cannot be having oxygen, nitrogen, halogen, nothing else. So it's only an arrangement of carbon and hydrogen. You could be having multiple carbons, multiple hydrogens. This is not fixed, but one thing is fixed, that it has to be having only carbon and hydrogen atoms. I'm giving an example. For example, if I have to choose between two compounds, let's suppose this is a compound A. It has so far 2 carbon atoms and apparently 6 hydrogen atoms, and there's this other compound. Let's suppose nitrogen is in group 5, so it makes 3 bonds. This is what I've tried to do over here. Now which one is going to be hydrocarbon? So my answer is going to be very flat. I'm going to say this is a hydrocarbon, but this is not a hydrocarbon. Why is the other one not a hydrocarbon? Because it has nitrogen atoms. So as long as it has even a single non-hydrogen, non-carbon atom, it's a non-hydrocarbon. Sorry. So we're going to be dealing with hydrocarbons for sure within organic chemistry, and their derivative. Derivative means the products made by hydrocarbons. So when we use hydrocarbons to make something, that something is going to be called derivatives. We are dealing with largely hydrocarbons, but at some point we'll be dealing with some derivatives as well, and we'll know कि अच्छा भाई hydrocarbons reacted with something and now we are getting a new product, so that new product has to be a derivative. The word derivative is very rare, seldom used within the organic chemistry, so we don't have to worry about it. What we have to worry about is the word of hydrocarbon. So when we talk about hydrocarbons, it means there are multiple carbons, there are multiple hydrogens, and they are making a compound. So we'll see how it happens. The idea is very simple. We know that carbon is in group number 4 and hydrogen is in group number 1. So when we deal with carbon, carbon has 4 electrons around the valence shell, in the outermost shell as well, and hydrogen has only 1. So carbon has 4 electrons in the outer shell, hydrogen has only 1 electron. Because carbon is in group number 4, so 4 electrons in outermost shell. That is very basic. Outermost shell, and hydrogen is in group number 1, so it has 1 electron in the outer shell, and that is why outermost shell. That is why hydrogen makes only 1 bond, only 1 covalent bond, and carbon makes only 4 covalent bonds. No more, no less. Simple as that. So whenever you are making a covalent bond, carbon should be radiating 4 lines and hydrogen should be radiating 1 line, because 1 bond is equals to 1 line. 1 covalent bond is represented by 1 solid line. So when you're drawing carbon, for example, your carbon could look something like this, with four lines coming out of it. It could be having 2 lines from one side, the other 2 from the other sides, whatever. It could be having 3 lines from one side, the other one from the other side, or 2 lines from 2 different sides. All you care about is the fact that carbon is making 4 covalent bonds, which means 4 lines are coming out of it. Hydrogen can be making only 1 line. So hydrogen can be making only 1 line. That's it. No more, no less. Let's see how we can arrange them. I'm just giving you a general idea. For example, you have 2 carbon atoms and you want to connect them, so that is one bond. This one bond will be counted for both. So you can't say okay, the carbon on the left side has made a bond, or you can't say the carbon on the right side has made a bond. This bond is made by both carbon atoms, so it will be counted for both. Now we know that carbon makes 4 bonds. This carbon has made a single bond so far. The one which I'm highlighting with a red pen has made a bond from the right hand side. It has a capacity of making 3 more bonds, so you can make 3 more bonds like this. I know this already, that the carbon which I'm highlighting with a blue pen right now has made 1 bond from the left hand side. So it has a capacity of making 3 more bonds. So 1, 2, 3. Once you know that your bonds are complete, you can simply fill in the hydrogen from the corners. So you can put hydrogens on the corners, because each hydrogen is making 1 bond, each line can get 1 hydrogen. That's it. Now you got a structure of organic chemistry. Now this is a hydrocarbon because it has hydrogen and carbon atoms. So you could be having a hydrocarbon structure with carbon and hydrogen atoms. You just have to be very cautious about making proper lines. I'm just giving you one more example, and we'll talk more about the hydrocarbons in the next video. For example, let's say I have 3 carbons, and I make a bond over here, I make a bond over here. Now I know that there are 3 carbon atoms, the one highlighted with a blue pen, one highlighted with a red pen, one highlighted with a green pen. Now the one on the right hand, the blue one, the one which has been highlighted with blue, it has made already 1 bond, right? From the right hand side you can see it has a bond. So you can make 3 more bonds. The one which has been highlighted with a red pen has made 2 bonds, one on the right hand side, one on the left hand side. So it should be making 2 more bonds, one from the top, one from the bottom. The one which has been highlighted with a green pen can make 3 more bonds, so 1, 2 and 3. Now to complete the final structure, we can put in the hydrogens from the corners, because each hydrogen can make 1 bond. So each line gets 1 hydrogen on the corner. Just end में we put in the hydrogens. And now we know that this is a structure with 3 carbon atoms, and you can count the number of hydrogens, so you will get to know that there are 8 hydrogens. So this compound has a structure of C3H8. The one on the top was C2H6. So this is how you make hydrocarbons. In the next video, we'll be talking about more structures and what are alkanes and alkenes. So stay tuned.